Tonight, we're meeting the universe's most terrifying monsters. Objects so extreme they break the limits of physics itself. First, let's meet a star corpse so dense that a teaspoon of it would outweigh a mountain. What if I told you that some stars collapse into objects so dense that a single teaspoon of them weighs more than a mountain? Neutron stars are what remain after a massive star explodes in a supernova. Gravity squeezes the core so tightly that electrons and protons merge into neutrons. The entire star shrinks to a sphere only 20 kilometers wide, about the size of a city. Yet it contains more mass than our sun. Their gravity is so strong that time itself slows near their surface. A falling object would hit the surface at 1/3 the speed of light. Some neutron stars spin hundreds of times per second, sending beams of radiation sweeping across space like cosmic lighthouses. These objects are so extreme that they stretch the limits of physics and force scientists to rethink how matter behaves at the edge of destruction. Now imagine that same dead star, but turned into the most magnetic thing in the entire universe. Imagine an object whose magnetic field is so powerful it could erase every credit card on Earth, from halfway to the moon. These monsters are a rare type of neutron star with magnetic fields 1 trillion times stronger than Earth's. Their magnetic force can twist solid crust like rubber. When that crust snaps, the result is a starquake, producing bursts of energy brighter than entire galaxies. A magnetar flare in 2004 passed through Earth and briefly changed our atmosphere, even from 50,000 light-years away. If you stood near one, just a few hundred kilometers, your atoms would literally be ripped apart by the magnetic field. Magnetars live fast and die young, calming down after about 10,000 years. But while they're active, nothing else in the universe can compete with their raw, violent power. What happens when matter is squeezed so hard that even neutrons collapse? You get something stranger than science fiction. A quark star is a hypothetical object even denser than a neutron star. If a neutron star collapses further, neutrons break into their core ingredients, quarks. What remains is a star made of quark soup, a form of matter that barely follows the rules of physics. These stars would be only about 10 kilometers across, yet heavier than the sun. Their surface might be so dense and smooth that mountains can only be a millimeter high. Scientists believe quark stars could shine with an eerie bluish glow and might rotate even faster than pulsars. No one has confirmed their existence yet, but mysterious supernova remnants and unusual gamma-ray signals hint that quark stars may already be hiding in our galaxy, waiting to be discovered. Some cosmic monsters don't stay where they're born. They wander the galaxy like invisible hunters. What's more terrifying than a black hole? A black hole wandering through space, completely invisible. Rogue black holes are black holes that roam freely after being kicked out of their galaxies, often by gravitational slingshots or collisions with other black holes. They travel through space at millions of kilometers per hour, swallowing anything unlucky enough to cross their path. We can't see them directly, but their presence is revealed by how they bend starlight or distort the motion of nearby stars. A rogue black hole could quietly pass through our solar system, and we wouldn't notice until planets began to drift out of orbit. Scientists estimate there could be hundreds of millions of these cosmic predators moving silently across the Milky Way, turning space into a dark, unpredictable wilderness. And finally, we zoom out to meet giants so huge they make our entire Milky Way look tiny. Imagine a galaxy so huge it contains more stars than every human who has ever lived, multiplied by 1 million. Ultramassive galaxies are the largest structures made of stars in the universe. Some contain over 100 trillion stars, with black holes at their centers weighing billions of suns. These galaxies grow by absorbing smaller ones, cosmic cannibalism on the grandest scale. Their halos of hot gas stretch for millions of light years, making them appear like glowing islands in the dark. When two ultramassive galaxies collide, the energy released can trigger star formation on a mind-blowing scale. These galaxies show us the true power of gravity, acting like cosmic engines that shape the universe's largest structures. Studying them also helps scientists understand how the universe evolved from tiny clumps of matter into the vast, majestic cosmos we see today. Thanks for watching, and don't forget to subscribe for more mind-bending journeys across the cosmos.